I feel dirty. This man sent his equipment to me a month and 16 Sundays ago. And hands are sticky. They're sticky. It is a Fatboy and a BullyDog. And I am supposed to do... There's no frickin' coax connector. Anywho, okay, so to Mr. BBI. This is name omitted to protect the innocent. But you call me Mr. Y. My 8-pill box got hot after two key resistors got... I'm not making this up. Get hot after 2 key resistor get to smoking and tie with a string. But I want you to check it well. Straight 6-pill is marked with string. Need to check both box well. Mr. Y. Return to UPS where sent the other one. Okay. And on this one I got another envelope and there's nothing in it. Okay. So everybody got that note? I'm not making that up. Oh shoot. Okay. I'm in a really funny mood today. I woke up in a really good mood this morning because I knew this is what I had to work on. I've seen worse. I've seen a lot worse. Let's look over here at the 8-pill other than it being absolutely filthy. This guy's going to spend a ton of money just getting this son of a bitch clean. That is totally smoked. Wow, that's dirty. I mean, that's... Look down in here between the transistors. Look at this. Ooh, it's filthy. Okay, so when we do the before and after shot, you guys are like, damn! This one doesn't even have a coax connector. The center pin on this one over here. Oh, come on. There we go. Okay. The center pin on this PL259 is... And then this one's missing one completely. I don't see any burnt 10 ohms. Okay. Whew. Got a long road to hoe, but we're gonna get there. All right, let me call my man. Tell him the good news that his stuff's up on a workbench. Tell him he's gonna owe me $1.5 million because I need to update my hepatitis shots here. It's not that bad. It's not that bad. They're just really, really dirty. What is going on over here on the remote plug on this one? Look at this. There's like phone wire hanging out of the back of the plug. Oh, gentlemen. Gentlemen, come here, babe. Bring that here. Look at my wife just come out.
Panda time.
She tells me it's lunch. Yeah, I'll be back. I'll be back. Okay, so now that it's clean, I can see something I couldn't see before. That is a burnt 10 ohm resistor. And that might have something to do with why this resistor here on the back is smoking. The other thing is the massive amount of burn that is right here. down underneath this board. And this tuning tube looks like it's seen better days. So we're going to come back to the 6-pill in a minute. For now, we're going to stay focused on the 8-pill. And let's see if we can get this running properly. We're going to disconnect all this stuff here, this phone wire. This is dangerous and dumb, very dangerous. But for now, we're going to pull these 2 pills, and I'm going to pull this tuning tube out, and we're going to change this a little bit. I don't feel comfortable letting this go out of here in this condition. This here for sure. This obviously has got to get fixed. This here, ugh. It gives me the heebie-jeebies. Okay, so I pulled the power wires out, pulled those caps out of there, which we're going to do a capacitance check on these here in a minute. I'm pretty sure they're shot. This setup here I don't like. These caps here, not a big fan of it. And let's go down here and let's take a quick look at the tuning tube. That can't be good. And this solder joint here is also cracked and broken. So the only one that's holding it down is this one back here. Now it's broke and that's broke. So none of that's good. So what I've got you here is a captive audience. Let's go ahead and let's grab our soldering iron. Oh man. Let's see if we can catch our microphone on the friggin' tripod stand one more time this week and knock it off. Sorry about that, everybody. Let's go ahead and make sure that's off there. And we'll do that there. And we'll slide that off of there. So see how this is burned through? Let's re-roll that again. Let me show you where that was at. You see that? So it's arcing over to this edge through the Teflon insulator, which we can see through. This has got to go in the trash. It's no longer safe to use. So our output power was shorting through our tuning tube, which if it was up to me I wouldn't hit it here, I'd hit it here, but they chose to attach it here, whatever. 6 dozen, 1 half ways the other. And we'll pull these caps here and replace them. Same with these caps over here. As we can clearly see, this has had multiple 100 ohm resistors on it. Looks like at least 1, 2, 3, at least 3, and it all comes back to this blown up pill over here. There was an imbalance, and it was shorting through and arcing over, and that right there will wipe out your pills faster than anything. So we really won't know if we've got any other damaged pills until we get this up and running. So that's bad. I mean, that's really bad. That's been burning for a long time. Bummer. All right, moving on. wanted to show you this. Not tight. Not tight. Now let me back the camera out here and I'm going to show you. Not tight. Not tight. Not tight. Not tight. Not tight. Here, let me get into this one. Not tight. Not tight. And we'll get into this one here. Not tight. Not tight. So let me ask you this question. Also not tight. Also not tight. Let me ask you this question. How well can the transistor conduct the heat to the heat sink if the transistor is not screwed down tightly to the heat sink? Not pointing any fingers at anybody, okay? But I would say there was a problem for a long time. I was surprised this doesn't have more pop pills in it than this. That's all I would say. I'm sorry, I just went to pull this transistor out and I'm like, wow, that's like so loose. That's not even. So like if you tighten this down, you tighten it down, you pull a torque on it, it's on there, right? This one was loose, and then I tried his partner and it was loose, and I'm like, well, look at this. It's like a Tijuana hooker. Screws will just give it up to anybody for anything. You fart on it and they fall out. Just saying. We'll fix it. I'll fix it. Have faith. Excuse me. So what we're looking at is all the old pill screws out of the box. I went to tighten them down and they felt like they were just on the edge of stripping. And I said, that's no good. So I went in and I backed one of them out and I went, oh, okay. So, I'm not going to make a big fuss of it, but I replaced all the transistor screws just because. Okay, that's the bad one. This is the one that's going to tell us the rest of the story here. Excuse me. On. Okay, this one's got a gain of 31, which is encouraging to me. The thermal compound on here is like dust. It's not even gritty anymore. So that's the bad one. This is our good one. We're going to take and get rid of these. So we take this bad Toshiba and we'll throw it up in the bag. We'll throw those extra transistor screws in the garbage. Let's go ahead and straighten out our tabs here. And then we'll get into our big giant bucket of used transistors. We'll find another one at the gain of 31. Let's put our little tester away for next time. Okay. Now, let's talk about these. Let's find out what our values are. These things have been a little hot. This is a 1200 and a 153. 136. And this one is a 1000 and Jesus. What? Two completely different caps. Close enough. I mean, they're close to the same for no joke. Within one puff. So technically that's correct. I got two caps here. This is a 100 and this is a 50. So yeah, all right. And that's 1,000. 1,000 and a 1,200 and a 1,250 or a 153 and then a 150. I cannot reuse these in good mental conscience. I just fucking can't. So, put them aside. Let's find ourselves a match 31. We'll put this all back together. Put the flybacks back in it. And let's start putting this back into one operational piece. Okay, so new tuning tube installed. Power wires upgraded. It's got metal clads on the outputs. Now here in the back. All the capacitors checked within specs, so instead of having them all cluttered around in this mess, I just remoted them and put them over here. It's got a new transistor in here, a gain of 31 transistor matched to its partner. Now there's one other little problem that we've got to address here. I don't know how this was ever working like this, but it was. We're looking at this wire right here. To me, that's a problem. Now I can tell there's been a lot of meat beaters in this situation. A lot of meat beaters up in this thing at some point or another. We're just going to pull this out and away from that piece of ferrite. So there's no chance it can touch now. Okay. There's been a couple meat beaters in here since Fatboy, so we're not pointing any fingers at anybody. We're just doing the best that we can to fix it right. So, new transistor, new pill screws, blah, blah, blah. Let's go ahead, we're going to hook this up, we're going to run it, and then we're going to jump over here to the 6 pill. The friggin' ground nut was loose. Oh man, fun times. Well, I know for a fact once it leaves here, every nut, bolt, and screw will be tightened and replaced at this point. So, okay, let's hook it up. Okay, so got our output tuner set. This cap, where'd I end up throwing the turd? Here it is. This cap that we just showed in this previous segment, where it doesn't even want that there. I took that out and all the problems went away. There was a capacitor here and a capacitor here at the relay. It makes sense what they were trying to do now. You can't have capacitance in both spots. I just did a whole video about this not too long ago. I think it was, they just released it today, so it's been a week ago now. The Fat Cat, Dave made Fat Cat video where I talk about how you don't want to do 2 points of tune, you just want to add it in one spot, blah, blah, blah. Anyhow, pulled that cap out of here and the input tune fell, or the input fell right out of it. So we're over here, this is a 1,000 watt in peak, 1,000 in average, 5 watt slug in reverse. We're gonna use a 5 watt slug, get my finger up there. 5 watt slug between the bench, 2950, and eventually we'll end up over here on the Stryker. So let me show you what I'm putting into this for drive. Make sure I got the amplifier off. Amp is off. We're on 12 volts. Hello, 1, 2. So 20 watts worth of drive. Let's show the pass-through tune, or otherwise your ability to hear through it and talk through it. Hello, 1, 2, deader and a doornail. This is what we're looking for. Okay, so with a 1/2 watt going in, the relay will latch. Relay latches. Hello. Hello, audio. We're seeing 5 watts worth of reflag. So, hello, 2/10 of input reflect with 20 watts going in. Hello, making roughly 500 watts. So, let's go down here And let's turn our voltage up. And we're going to come up to about 15.1, 15.2, somewhere in there. We'll retest. Most of these guys' idling voltage is around 15 volts, so. Hello, that's better. Hello, about 700 watts, give or take. Hello, audio. 725, 730, somewhere in there. Okay. So our golden child there. So now that we're on the higher voltage, we'll come off the 2950. And we're going to go to the 955 Stryker D-Rail radio. Just straight radio drive. And I bet you we see over 1400 watts. But about 125 watts worth of drive. Okay, so we're going to shut the amp off. The amp's off. Hello, 1, 2, 1, 2. It's about 120 watts of drive. Goodbye. Hello. So 500-600 bird, give or take. We're going to go to 2x. If it's your first time watching. When this needle goes over here to the 100, that's 2,000 watts. So it makes the middle of the meter movement right here at 50. 40, 60, this hash mark here at 50 is 1,000. Next big hash mark is 12. Next big hash mark is 14, 16, 18, 2,000. Okay. Seeing about 1,650, almost 1,700 out of it. 16 some change. Let's go up here. I gotta manually drive the camera now. So 3/4 of a watt and falling. The front of the Stryker's happy. 1, 2, 1, 2, 1, 2. It's looking good. It's looking real good. So while that's booting, let's pan out here for a second. What I have to do to get this thing, now technically I'm done. I could throw the tins on this thing and be like, I'm done. But there's a part of me that wants to take this dumpster fire of a tin, and this is after I've washed it. It's still got all this stuff going on the outside. I want to clean this up. I really do. Really want to clean this up. So I'm going to go take care of that real quick, and we'll be back. Okay, before we run away here real quick, I want to show you this. I got the dead key on the Stryker turned up to about 10 watts. That's we're at 0 through 200 megahertz. So we're throwing a 10 watt carrier into it. Here's the amplifier. Little tiny harmonics. Almost 50 dBs plus down, 48 dBs down, so not too bad. Spectrally, not too bad. Okay, let's go do the case real quick. This is, well, that's a whole lot more data on the screen. This is starting to get a little ridiculous at this point. All right. Fan looks like it's been used to pump dog dirt for the last 6 months. Got him a new fan guard. Got the cabinet all cleaned up. Short of the grinding marks that are on the side. I can't do anything about that. You can tell that a screw or something, yeah, right here, got effed off. Instead of just cutting it with a Dremel and backing it out, they ground the... Anywho, let's clean the fan. Okay, so... let's dial the f-stop down here a little bit. Case is all redone. Inside of it's all cleaned up. It's been cleared on the inside so it won't corrode anymore. I got the fan cleaned up so it actually can move some air. I swear, as I was finishing the case, it smelled like maple syrup. Like somebody had spilled maple syrup at some point all over the fan and the top of this amp. I don't know. This box has had a hard life before it got here. But I put a lot of love into it, and we'll see how well it decides it's going to stay in one piece. Max power test here. It's a 1,000 watt slug in average and a 1,000 watt in 2X. So, hello, 650 to 700 bird. And of course, that's just hitting it with the derail 955. So if we hit it with a 2-pill, like a dual 2290 or something, it's going to perform even better than that. Well, we're done here. Done. Now we're going to move on to that. I think I'd be doing the transistors more justice if I'd pull them out and put them in a new cabinet, but I just don't think that's in the budget. So these coax connectors are held in with pop rivets. I'm going to have to drill out both of these, put brand new coax connectors on them. I have no earthly idea what this little ground wire is for. None. No clue. So we're going to remove it. Of course, it's going to need new power wire. So as soon as I get the coax connectors replaced, then we can go and hook up the keying circuit once again. I'm going to undo this relay to get it out of the way so I can work on the coax connectors. But Cucamonga, this thing is bad. It was just so horribly dirty. BullyDog. It sure looks like the logo on the BullyDog watt meters. I don't think it's the same though. I'm pretty sure it's not, so we're not going to get into that anyhow. Alright, so connectors, power wire. We'll be back when we can test it to see how many transistors are popped or what's broken. Hopefully not too much. Well, it's now 12:30 at night. This box has fought me like it just doesn't want to work right. We got all the bugs worked out of it now. See, first things first, this was our output tuning capacitor, which there's no way this has got a high enough kV to handle a 6-pill. There's no effing way. This is straight out of Chinesium bullshit. So I went ahead and I replaced it with a capacitance tube, which is probably 25 more kV than what that other cap was. Got the output dialed out. It wants to make power. It just didn't want to have its input settle down for anything. So I started playing around with the input capacitance on these input transformers, and I found that 1300 puff, which, taking into account the number of turns and the way the splitter circuit is built, it gives me a hint. And in the old school days, we do 1,000 here and we do 1,200 here. The old timers that are out there, you know exactly what I'm talking about. But at 1,300, something magical happened. The input actually fell down to something acceptable. It had a 120 puff capacitor on the input, ended up wanting a 75, but I had to add these 3 caps. In that process, I figured out I had an intermediate short in this piece of coax, and it was on this side right here. You could just jiggle the relay a little bit and I'd lose all input and it would all, the SWR would just jump up through the roof. So I had to replace the input coax. And last thing was the input tune didn't want to play. Did not want to play. Not input, but I mean pass through. So the RF coming in, going down through the relay and coming out the connector. It just didn't want to play. Ended up being the sniffer capacitor. That's the capacitor that we use to tie into the keying transistor. This is a 50 puff cap. Well, everybody that's in the business knows that you never want to go that high. That adds too much capacitance, inductive capacitance, or not, coupled capacitance to the keying circuit here. And it'll screw everything up. It'll screw up your input tune, it'll screw up your pass-through tune. Because remember, this capacitor goes straight through the transistor and goes to ground. I can see it. So This whole time I've been fighting the input tuner on a 50 puff capacitor as our sniffer. Drop that down to 10. Now look at what happened. We are on the RCI 2950. Hello, 1 2 1 2 1 2. And by the way, we are going to use the spectrum analyzer here in a second. Hello, 1 2 1 2 1 2. Okay. It's a 5-watt slug in reverse between the 2950 and the BullyDog 6-pill. It's dead nuts low. And I'm here to tell you that took a few minutes to figure out. Now, this also took a few minutes to figure out. So we're putting into it about 4 or 5 watt carrier. We're making a nice solid 800 watts with about 25 watts worth of drive. Let's go over here. That's the amplifier. That's the radio. Amplifier, radio. Amplifier, radio. Okay. Let's go up here. Let's look at the input tune. Now, before I started, it was oscillating, jumping back and forth between infinite, which slamming the 5-watt slug in reverse, slamming it in the corner with only like a couple watt carrier, and that's because the coax was shorted out. Hello. Hello. Half a watt. That was a dynamic pain in the ass to get it that low. No kidding. To get it low and stable. But now on the output side, 1 2 1 2 1 2. Everything's balanced. Everything's happy. Okay, let's change out to the derail Stryker 955. I had so much fun getting the old coax connectors off of this thing. It was like they used the cheapest pop ribbons that money could find, and then they used the cheapest PL259 connectors that money could find, or SO239 connectors. I went to go drill out the pop rivets, and the whole connector shattered, and then the pop rivet would just free spin. So then I had to cut it, take the rivet piece out of it, had to bang the rivet back through, grab a hold of it on the backside and jerk it out. This one was still intact, but the center journal was floating back and forth. That one presented even more of a challenge. I probably got an hour trying to get these stupid connectors off, but it's got 2 brand new coax connectors on it. Teflon, gold plate, max gain system, good high dollar quality connectors. This thing just did not want to play. It just didn't want to play. So now we're on the Stryker, the derail Stryker. Let's go ahead and we'll turn the amp off. We're still in 1X. Hello, audio. So we're going to swing about 120 watts drive into it. Let's go over here. First off, radio, amplifier. Radio, amplifier. Okay. Let's go over here. Hello. We're slapping that 1000 watt slug and peak in the corner, which is cool. I dig that. So now we're going to go up to 2X. Like I explained in the previous segments of the video. All the way over here is 2000 watts. This hash mark here between the 40 and the 60 right here is 1000 watts, 12, 14, and so on. We're going to get about 1400 watts out of this little 6-pill with 125 watts worth of peak drive. Hello, 1 2. Okay, no problem. Here's what I think is neat. This took hours to achieve. Hours and hours and hours to achieve this. Hello, 1 2. Now look at this. Hello, 1 2. That is new. That's from the sniffer circuit. Hold on, I got to add a little bit more capacitance to the input tune. If you take 40 puff of capacitance out here, you have to add 40 puff worth of capacitance here because the total capacitance has to stay total. Set the input tune up, Then I changed this cap, and I forgot I needed to compensate for it for here. So it's a 75 plus 40 puff. Still a far cry from 120. So anyhow, let's go up here and lock the camera down, because I need both hands to do what I'm doing here. So went from showing an SWR of 3 on the front of the radio to an SWR of less than 1.5. Hello, 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 hello. Hello, 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 hello. Hello, hello. To a whole half a watt and a 1.4 on the input. That's as low as we're going to get with this current setup, without dramatically changing a bunch of stuff on the inside of the box further from this, like getting rid of all these little wire inductors with wire hoops that run over the wires. Just don't think this guy's in the mood to spend the amount of money it would cost for us to rewrap this, rewrap these, change these out to coax, make these independent. This guy's going to be happy with this 6 bill. Because remember, I wasn't doing anything when it came in here. Hello, 1, 2, 1, 2, 1, 2. Make a 1400 pretty easy. Want more out of it, put more than 125 watts of drive in it. So I'm done. I'm done with this. The other thing I did was I took about an hour this evening. This case looked like the fan had been dipped in baby food. Man, there was mud running out of this fan when I cleaned it. I went ahead and surface prepped and sanded this case. Beat all the dings and the dents and the wobbles out of it for the most part and got it cleaned up. I swear somebody poured maple syrup all over this amp, just like the other one. It stunk to whole high heaven. It was covered in white spots like this, so I just went ahead and sanded the whole thing back. I would have sanded the front, but I didn't want to let the vinyl graphics get all screwed up. Like I said, this is originally a BullyDog built. I don't know if it's the same guy that makes a BullyDog watt meters. I don't know. All I know is the thing is running. It's running really good, and he didn't have any blown pills. So now, let's see if I can make good use of these hollywoggered out holes on the case and see if we can get this thing to come back into one piece now. Well, I got the case to finally take some screws. So it's all appropriately shut up now and it's not completely dead. This thing turned out 10 times better than I thought it could. I even took the fan guard off and repainted it. First I wire brushed it and took all the rust off of it, and then I repainted it. It was black. The top of the fan was completely covered in rust and some brown substance, most likely caramel of some kind. And I was able to get that all cleaned off. And underneath the caramel was rust. So I went ahead and I painted the center of the fan so it didn't look all fugly. And I cleaned off all the fan blades so it could grab air. These two boxes have represented more time cleaning. Like, I think I would have done the transistors more due diligence if I would have just simply pulled the pills out and built 2 brand new boxes around the 2 pills, or the set of pills, just because everything was so dirty. But it's okay, it's fixed. This old girl is restored back to better, or at its original glory. I mean, getting a cabinet straight was a challenge. This whole side had whoop-de-woos in it, just like the other one. It like somebody took a grinder to the side of the case. So to get it square again, I had to resurface, beat everything square, and then I had to resurface everything to make it look right. So I hope my man that gets this appreciates the amount of work that's gone into both of these boxes. Hello, 1, 2. Everything's working just the way it should. Hello, 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 1, 2. Hello, 1, 2. I'm going to call it a win. Well, gentlemen, I want to say thanks for your time. Thanks for tuning in and following along and watching me work my magic. These two were some very seriously beat down sorry excuses of CB amplifiers if I've ever seen any. But they are completely restored back to their former glory. clean, painted, prepped, and fully repaired and fully functional again. A lot of work, but it's worth it. It's worth it. Gentlemen, my name is BBI and I want to say thank you. Got to give a shout out to Siglant, XS, MechMan, Bird, Coaxial Dynamics, all of you, and to my Patreons. If it wasn't for my Patreons, I wouldn't be here, and that's no joke. If it wasn't for all of you, I'd be out on the corner bumming it. So say thanks. I will be taking on new work in September of this year for 2023. That is my work schedule. I'll probably be taking on about 200 to 250 amps. That's it. You will call me and get a number. I will give you the number you're going to write on the outside of the box when you ship it. That's the process that we're going to go through. I'm going to start explaining that in every single video going forward. That's why nobody can go, well, I didn't know I wasn't supposed to just send it to you. You need to call first. I'm going to give you a number. I can't do what I happened 2 years ago. It's not fair to ask people to wait 2 years to get their equipment fixed. And I didn't think that everybody would send me their amp that quick. I'm grateful that you all did, and I'm grateful that only about 2 out of 800 have not, you guys all paid and took care of your bills. I got 2 sitting here that, I don't know. It is what it is. Gentlemen, I just say thank you to every single one of you guys. It's 1:30 in the morning now, and I'm done. I hope you enjoyed it. I'll see you. Click, click.